I'm using a dataset with features x and a target variable y. The features represent characteristics of the data points, and the target variable is what I'm trying to predict. In this case, y is binary. It can only be 0 or 1. It's like trying to predict whether a customer will buy a product, 1, or not, 0, based on features like age and income. These are the independent variables, the values I have for each data point. Think of them as the characteristics used to make predictions. I have 4 features in a matrix. Each row is a data point, and each column represents a different feature. This is the dependent variable, what I want to predict. It's the outcome. In this case, it's a binary value. Each element in y corresponds to a data point in x. This shows the actual values for the features, x. Each inner list represents a single data point and contains the values for the 4 features. For example, the first data point has feature values 1, 2, 0, 1. These are the corresponding target variable, y, values. Each value, 0 or 1, indicates the outcome for the corresponding data point in x. I'm using the chi2 function from the popular Python library Sklearn. It's a statistical test used for feature selection, especially helpful when dealing with categorical data. This function helps me determine which features are most relevant to my target variable. The chi2 function gives me 2 important outputs, chi2 scores and p-values. The chi2 scores indicate the strength of association between each feature and the target, while the p-values tell me the statistical significance of that association. I'll use these to determine which features are truly impactful. These are the results from the chi2 test. Each score and p-value corresponds to one of the 4 features. The scores give a measure of association, larger is better, while the p-values help assess statistical significance. This is the threshold I'll use to determine if an association is statistically significant. If a p-value is below 0.05, I'll consider the association significant, meaning it's unlikely to have occurred by chance. I will decide which of the provided statements are true or false based on the chi2 scores and p-values, using the significance level to interpret them. It's a multiple-choice question to test my understanding of the chi2 test and its results. It is the question about interpretation of the results. This is what I need to do, based on the interpretation of the results. I'm looking at the results of the chi2 test. The chi2 scores tell us how much each feature contributes to explaining differences in the target variable. The p-values, which are more important for this analysis, tell us whether this contribution is statistically significant. A low p-value suggests the feature is likely meaningfully related to the target variable. A high p-value suggests otherwise. This p-value is above 0.05, my significance level. Therefore, I conclude that there is no statistically significant relationship between feature 1 and my target variable. Like feature 1, this p-value is also above 0.05. I conclude that there's no significant relationship between feature 2 and my target variable. A p-value of 1.0 is the highest possible value. This definitively tells me there is absolutely no association between feature 3 and my target variable. Just like features 1 and 2, feature 4's p-value is greater than 0.05. Hence, I conclude there's no significant relationship between feature 4 and the target variable. This is my threshold for determining statistical significance. If a p-value is below 0.05, I reject the null hypothesis and say there is a statistically significant relationship. Otherwise, I fail to reject the null hypothesis, meaning the relationship is not statistically significant. It's like setting a bar. If the p-value is below the bar, 0.05, it passes the test. I'm using Sklearn, chi2 function, a powerful tool for feature selection. This function helps me determine which features in my dataset are most important for predicting the target variable. It uses the chi2 statistical test, which is especially useful when dealing with categorical data. The chi2 function gives me 2 key outputs, chi2 scores and p-values. The chi2 score measures the association between each feature and the target variable. Higher scores suggest stronger relationships. The p-value tells me the probability of observing the results if there's actually no relationship. A low p-value means the association is likely real, not just random chance. Here are the actual results from my analysis. For example, feature 1 has a chi-squared score of 0.8 and a p-value of 0.37. Feature 2 has a score of 0.73 and a p-value of 0.39. Feature 3 has a score of 0 and a p-value of 1. And feature 4 mirrors feature 1. These are multiple choice questions based on my chi2 results. Statement A asks if feature 1 is statistically significant. Statement B asks if feature 2 is not statistically significant. We'll decide whether these statements are true or false based on the p-values and a significance level, alpha, I've set to 0.05. A p-value below 0.05 suggests statistical significance. This shows my dataset's features. Each row represents a data point, and each column represents a different feature. I'm trying to understand how these features are related to my target variable, y. For example, the first data point has feature values 1, 2, 0, and 1. I have a dataset with features, x, and a binary target variable, y, which is either 0 or 1. I want to find out which features are the most relevant for predicting y. To interpret these results, I will compare each p-value to my significance level, alpha equals 0.05. If a p-value is less than 0.05, I'll say there's a statistically significant association between that feature and my target variable. If it's greater than or equal to 0.05, I'll say that there's not enough evidence to conclude a significant relationship exists. My significance level, alpha, is set to 0.05. This is a common threshold in hypothesis testing. It means I'm willing to accept a 5% chance of incorrectly concluding that there is an association between a feature and the target variable when there actually isn't one, a type 1 error. My dataset contains both categorical, represented by small numerical values that act as categories, and numerical features. I'm applying the chi-squared test, considering the numerical features as categories. This needs to be considered during interpretation, as other tests might be more appropriate if the numerical values were considered continuous. I'm using a dataset with features, x, and a binary target variable, y, representing 0 or 1. The features are numbers, but we can think of them like categories for our analysis. This shows the actual data. Each row is an observation, and each column is a feature. For example, the first observation has a value of 1 for feature 1, 2 for feature 2, 0 for feature 3, and 1 for feature 4. I'm using the chi2 function from Sklearn to perform a chi-squared test. This statistical test helps me figure out which features are most related to my target variable. The chi2 function gives me two things: chi-squared scores, which measure the association strength, and p-values, which tell me the statistical significance of the associations. These are the results from my chi2 test. Each score and p-value corresponds to a feature in the dataset. A lower p-value suggests a stronger relationship between the feature and the target variable. I need to interpret these results. My significance level, alpha, is 0.05. If a p-value is less than 0.05, I'll consider the relationship statistically significant. Otherwise, I won't. I have some multiple choice questions to answer based on my analysis of the chi2 test results. I'm using a chi-squared test to pick the most important features from my dataset. This is a common method in machine learning for feature selection. I have a dataset with 4 features, columns, and 5 samples, rows. Each sample has values for the 4 features, and a corresponding target variable, y. The chi-squared test will help me determine which features are most associated with the target variable. Here are the results from running the chi-squared test. The chi-squared scores tell me the strength of association between each feature and the target. The p-values tell me whether the association is statistically significant, based on the selected significance level. Remember, a low p-value indicates a stronger association. I'm using a significance level, alpha, of 0.05. This means I only consider an association statistically significant if its p-value is below 0.05. If the p-value is less than 0.05, I can confidently say that the feature is related to my target variable. Otherwise, I can't make that conclusion. Based on my p-values, I decide which features to keep and which to discard. Features with low p-values are good predictors, so I'll probably keep those. Those with high p-values might not be so useful, so I'll probably consider removing them. I'm using the chi2 test to find out which features are important for predicting my target variable. The chi2 test is a statistical test that tells me how strongly each feature is related to the target variable. It's particularly useful when I have categorical data, or numerical data that can be treated as categories. The chi2 function in scikit-learn is what I use to perform the chi2 test. It's a handy tool for doing this kind of analysis. Scikit-learn is a popular Python library for machine learning. I'll use scikit-learn's chi2 function, a statistical test, to see how strongly each feature in your dataset relates to the target variable. Think of it like this. We're investigating whether knowing the value of a feature helps us predict the target variable. For example, if we look at a feature representing, has a pet, and our target is, allergies, we'd like to check for any relationship between pet ownership and allergies. It's like playing detective. chi2 helps us quantify this relationship. The chi2 function gives us two important things. First, chi2 scores, which measure the strength of association between each feature and the target. Second, p-values, which tell us the probability of seeing the observed association if there were actually no relationship. A small p-value, typically below 0.05, suggests a statistically significant relationship, meaning the association is likely not due to random chance. I'll use a significance level, alpha, of 0.05. This means I will consider a relationship statistically significant only if the p-value is less than 0.05. It's like setting a threshold. If the p-value falls below that line, I'll conclude there is evidence of a relationship between the feature and the target. Otherwise, I won't. The lower the p-value, the stronger the evidence. This is our dataset. Each row represents an observation and each column represents a feature. This is what we're trying to predict. It's a binary variable, meaning it can only take on two values, 0 or 1 in this case. This shows the actual data points. Each inner list represents a single observation, with values for each of the four features. For example, the first observation has a value of 1 for feature 1, 2 for feature 2, 0 for feature 3, and 1 for feature 4. The corresponding target variable values for each observation. For instance, the first observation is associated with a target value of 0. This is the quiz section, testing your understanding of the analysis of the results obtained by applying the chi2 test on the provided dataset and target variable. This shows our data. I have 5 samples, each with 4 features. Think of it like this. Each row is a person, and each column represents something I'm measuring about that person, like height, weight, etc. These are the results of applying the chi2 test. The chi2 scores themselves aren't that important to interpret directly here. It's the p-values that tell the story. The p-value for each feature tells me the probability of observing the data I saw if there's actually no relationship between that feature and whether the target variable is 0 or 1. I'm testing whether feature 1 is related to the target. The p-value for feature 1 was about 0.37. Since that's above 0.05, my significance level, I don't have enough evidence to say that there is a real relationship. This statement is false. I'm looking at feature 2 now. Its p-value is around 0.39, which is also greater than 0.05. Therefore, I don't have enough evidence to say it's related to the target variable. This statement is true. This is a core principle of hypothesis testing. A smaller p-value suggests it's less likely that I'd see the data if there's no relationship. A smaller p-value means stronger evidence against no relationship, so the statement is true. The chi2 test usually works best with categorical data. Although my features are numbers, I have a limited range of values. I can almost think of them as categories. So, while it's not perfect, the chi-squared test is not completely inappropriate here. The statement is considered true.